Hi, everyone. Thank you for coming. My name is Alexander Fischer. I lead the reliability teams at Yandex Go that are responsible. So, where to start? First of all, we need to define what reliability is. And in our terms, reliability is the ability of a platform, of a system, to survive failures and keep working smoothly in a given period of time. And a preferred period of time is always. For example, we have a Friday evening, we have a rush hour, and we have a holiday at Friday evening. And everyone want to go to the city center for family dinner, for some kind of celebration. So we have a rush hour, we have spikes in rides, so we have a spike in CPU load. But we are still working. That means we are reliable. Okay. So next, I want to give you a context. What is Yandex Taxi? First of all, 25% of Uzbekistan population uses it. Second, technically, it's 1,000 database clusters. That's a lot. Third, we have a microservice architecture, and we have more than 1,000 microservices. What is a service, or what is a microservice? Well, when you open the app, you see, for example, order button. That's one service. We have, you see, color of the car. It's a second service. Or, for example, when the driver receives the order, it's a third service. And we have thousands of them. So it's a distributed system. It's complex. That's main point, it's complex. And at a peak load, we have 600,000 requests per second on our load balancers. That's how we do. Okay, next important thing, we work across the Uzbekistan at every major city, being biggest city being Tashkent, and most important for our business is Tashkent. I will talk later why it's important. So every geography has its own reliability issues at different times. Okay, next, meet our team. We have a 3 team that most important for reliability, but every backend engineer, every engineer at Yandex Go works somehow for reliability. So my team can go to every engineer at Yandex and ask him for some reliability feature. First team is SRE, Site Reliability Engineer. This term is coined by Google, I think 10 to 15 years ago. The system engineers who are responsible for databases, for infrastructure, for traffic, for load balancer, so they operate our infrastructure at scale. Second team are software engineers who code reliability features into the product, and they code reliability tools. I will be speaking a bit further. And third team, last but not least, one of the most important team, coordinators. Not all companies have coordinator team, but we have. Who are they? Okay, coordinators team are senior software developers, usually team leads, who know very good some part of order cycle of taxi. So they're experts, they have expertise, and they're responsible 3 days per month. They're responsible for all incidents across Yandex Taxi. So right now, my teammate, because I'm a part of this team, I'm a part of coordinators team too, and I have 3 days per month. I have a 24 hours per day duty on call duty, and we are responsible for every issue. So we need to coordinate to and to fix it, to create incident, etc. So it's a coordinator team. So we choose some kind of senior developer. So you can be too. Everyone can be a coordinator team. Okay. Next, imagine your future engineers, your future managers, and I suppose you're being best engineers in your country. And for example, maybe you will be working at Yandex Taxi. So, and you are given a task: make a system reliable. Where to start? What to do? How do you think? What matters most? Where to start? Do you have any ideas? What matters most for reliability? I just want to monitoring, observability. Okay, that's one. Any ideas more? Servers? Servers uptime. So hardware uptime. Okay, hardware uptime is most important for reliability. Okay, any ideas more? Huh? SLA, service level agreement. Good one. Okay. User experience. Wow. Someone thinks about users. That's great. That's great. What? Scalability. Okay. Maintenance. Okay. Let's go. Most important for when you just start, you don't know anything. Most important, it's to know your business. And before metrics, before servers, hardware, dashboards, monitoring, scalability, you must understand the business model. You must understand the user journey, user experience. And because reliability targets and goals depends on how the service is used in real life. That's what important. What are the city patterns? What is the even culture landscape in the country matters. It really matters. In one country, I know one country, the taxi did work for 3 days because of a holiday. 3 days, no taxi. So only by aligning with a business context, you can set meaningful targets and meaningful goals. Okay. So, in our view, at Yandex Taxi, we have 3 pillars for reliability system and framework. It's goal setting process and goal setting. It's processes and software tools. And it applies to any city. So let's break down one by one. Goal setting is where to start. And in your future careers, start with goals. Start with definition of success. So that's why, because we need to focus our team and focus our resources for meaningful goals, for important goals. Goal setting, it's a definition of success and gives a direction and it gives priority. Goal setting consists from 3 things, 3 artifacts. It's a reliability model, it's risk matrix, and incident criteria. That's how we prioritize our work. Start with reliability model. So you need to have it. That's most important idea. You need to have it. Reliability model is a description of what do you think reliable is for your service. So you go to CAO, you go to ISAT, yeah, or you go to CTO, Ilya Rubin, it's him, and you ask him, what is important for a taxi? What is not important for a taxi? And you have an answer. It's crucially important for a taxi, for example, not to have downtime more than 15 minutes. That's important. What is not important? And he says, well, it's okay to have a downtime for 2 minutes. It's okay. That's reliability model. And it's described with a metrics. And you have different metrics. You have availability, that's measured count-based or minute-based, time-based. You have a mean time between failures, between downtimes, and you have, for example, mean time to recovery. It's um, time you fix the system. It's a downtime, 15 minutes, 2 minutes, etc. Next important idea that reliability model for different services is different. There is no one reliability model that suits all. That's just idea I want to give you. I worked for my career that spans many years. I worked at different projects. I worked at cloud. I worked at taxi service. I worked at email service. I worked at food delivery service. All of them have a pretty different reliability models. For example, what is a cloud like Yandex Cloud or Google Cloud? It's some kind of internet service where you don't have an offline part. You don't have drivers. You don't have riders. You don't have rain. You don't have holidays. So for the cloud, you need to provide API endpoints and servers uptime for 9999, 4 nines. What are 4 nines? 4 nines in downtime means 52 minutes downtime per year. Only 52 minutes for the whole year. That's cloud reliability model. So we can say for projected availability of a region or API endpoint must be 4 nines, must be 52 minutes per year. For a taxi, it's different because you can have a lot of downtimes by 1 minute or 2 minutes. Why? Because the rider and driver can wait for a brief period of time. We can wait for 2 minutes, but we can't wait for 1 hour. For example, if the taxi won't be working in Tashkent for 1 hour, it's a part of urban infrastructure. That means that people will go to subway, they will go to bus, and it will be a huge problem for a big city like Tashkent if there is 1 hour downtime. So for taxi, it's very important MTTR, mean time to recovery. No more than, for example, 15 minutes. That's our target. Email service. Email service like Gmail or wonderful Yandex Mail, use it please. What is the difference between Yandex Mail, Taxi, and Cloud? The pattern of usage of email is that you read it in the morning on the work, before work or on the work, for example, 10 a.m. And in the evening after work, you read your home email, right? So 2 hour downtime at noon doesn't really matter. You can wait. Yeah, and you will read all the emails later. And when you read it, you see the advertising. So the service, it won't lose revenue because you will see the same advertising later. And less service is search, Yandex search or Google search. What is the difference between cloud, text, email, etc.? If the search service have a 2 minute or 5 minute downtime, it loses all the revenue. All the revenue goes to competition. If Yandex search doesn't work for 5 minutes, all the requests and all the advertising revenue will go to Google. If Google has a downtime for 5 minutes, all the requests, all the revenue will go to Yandex. That's the difference. And that means that their reliability model has at least 4 to 5 nines. So every minute, every second of downtime of search service means revenue lost forever. Okay, let's go. So we have reliability model for taxi. Then we need to have a risk matrix. What is a risk matrix? It's all the things that can lead to downtime or lost orders because At taxi, we define four nines in lost orders. That means 4 nines means we can lose 0.00001% of orders, all orders. Like 1,000 for 1 million orders we can lose. And risk matrix is a thing from incidents and from expert opinion of coordinators and SRE engineers, all the things that can lead to downtime, prolonged downtime, and losing orders and revenue. It's buggy releases, denial of service attacks, loss of expertise when it's very important, and reliability, because reliability depends on expertise of engineers. And when some engineers rotates to other projects or to other company, you lose expertise. And when you lose a lot of expertise, like half of your team rotates to other project, you have less reliable service because you lost expertise how to fix it. It's very important to have engineers with expertise, and you cannot handle big spikes in load. That's a risk. That's an example, but it's a real life example. Then you have probability of this event, where 1, it's never happens, and 5, it always happens. It happens every week. It's probable 5. And you have second dimension, impact, where 1, we don't have an impact, and 5, it's a full downtime. Then we multiply probability to impact, and we have a risk level. Then we have priority list. Why we need priority? Because we have limited resources, we have limited budget, and we need to focus on what is most important. It's a first key idea. Second key idea, that robust mitigations can be more valuable to reliability than final solution. Because if final solution needs 2 years and $1 million, and you have a mitigation that needs 1 week and $1,000, better mitigate. So you need to update the metrics regularly, quarterly, or at least twice a year, because risk changes. You mitigate some risk, you have new risks like meteorite or maybe aliens. It's new risks. You need to add it and you need to mitigate it. Okay. Third artifact is incident criteria. In a big company like ours, there are hundreds of incidents per year, almost 1,000. And not all of them are important. Most of them are not important. Like 90% of incidents, it's like you don't see a color of the car. It's not that important, you can still ride. So somehow we need to prioritize incidents. So we need incident criteria. For example, a taxi. If we have full downtime for more than 3 minutes or 5 minutes, it's a major incident. It's very important. If we lose, for example, 10,000 orders per 10 minutes, it's a medium incident. It's not a lot, but it's still important. It's a medium. And if you don't lose the orders, if the users don't see the impact, it's a minor incident. Example of a minor incident, for example, there is a control panel for taxi managers, and it doesn't work. It doesn't work. It's a minor incident because you users don't see it and drivers don't see it. It's a minor incident. Or for example, it's an incident when you didn't lose any order. It's a minor. So we classify, and this incident criteria, it reflects real impact on riders and drivers, because we are two-tier marketplace. We are marketplace for driver and we are marketplace for riders. Okay, so we know our business. we have goals, we have a reliability model, we have risk matrix, we have incident criteria. But now we need to implement it in real life. And for that, we need processes. And processes, this is some actions you repeat every day and every week. So it's a system and framework to execute and maintain these set goals. So let's start with a coordinator process. Coordinator Institute, it's an on-call duty. As I said, it's a team of 10 senior software engineers and site reliability engineers like me who know the taxi very well. And they have on-call duty 3 days per month. So, important people, we have a coordinator school because we need to train coordinators systematically before they go to production. Because every coordinator must be sure that his colleague, his coordinator, he can be trusted on production. So we have a text course that explains how taxi works, what are most important metrics, how alerting observability works, how different parts of microservice architecture works, etc. Then we have testing environment. And we have on-call duty on testing environment too, except weekends. And new coordinator can be tested on this testing environment before going to production, so he can feel what is on-call duty. And he must learn how to apply our playbooks, our tools consistently before he goes to production. Next is incident retros. We call it retros. At Facebook, they are called live site reviews, LSR, and they are public. What is LSR or retros? When the incident happens, something doesn't work, we have a ticket, and the team responsible for the downtime or for incident, they must write root cause incidents, timeline, action items, how to prevent it, how to make it not happening again. And retros is an event every week. Every week we gather, we take major or medium incident or some interesting incident, and there is a responsible team. For example, color of the car was down for 1 hour. And this team must explain why and what they want to do to prevent it. And the coordinator team must challenge them. So they ask questions. Why you did that? Why you didn't do that? What plan is this? And coordinator, they're pretty experienced, seasoned engineers. They can have ideas and they can help. Why we need it? Because it helps us to raise maturity of reliability at every team. Basically, it's a continuous improvement for reliability. Next process is incident simulations. So, reliability engineers struggle with entropy. And when we do our job good, we don't have major incidents. We don't have a lot of incidents. And if we don't have a lot of incidents for 3 months, for 6 months, our tools and our skills to fix the taxi get rusty. We forget how to fix it. It's simple. No incidents, no practice, and don't use it, lose it. So, we need to create incidents. We create incidents by ourselves in a testing environment. So, every week at Tuesdays at noon, the coordinator team and SRE engineers gather. One coordinator breaks taxi, and one coordinator must find root cause and fix it every week. It's called simulation. And we process it in our incident management. We process it like real incident. So we have a task, we have a root cause, we have action items, etc. Because our testing environment is like production, just without real users. We have virtual users. So, and it's good for betterment of our skills and our tools. Next is some kind of part of chaos engineering. Yandex as a company has many data centers, and all our servers are in different data centers. But what if data centers is down completely? The meteorite just turn it off, or there is a network connection problem. What we do? We need to be sure that we are working without one data center, any data center. That's very important. So every 2 to 3 weeks, Yandex as a company turns data center off. Every 2 to 3 weeks. And all the services like Yandex Food Delivery, Yandex Taxi, etc., they have drills. And at Taxi, we have our own data center failure simulation every 2 weeks to be prepared. So we turn all the servers in this data center, all of them, and we see what breaks down, and then we fix it. And the payoff is much stronger than error budget and errors that we have during these drills. So we expand error budgets to find why we can't live without data center. And that's a part of chaos engineering. Okay, last process is, it's a story of the last year. It's SLO review. SLO means service level objective. It's a term coined by Google also, I think, 10, 15 years ago. And what is SLI? SLI is indicator. Indicator is just a number. For example, uptime indicator is 4 nines. It's indicator. What is objective? SLO. Objective means we set the target on the indicator. For example, we set the target. We want 4 nines. It's a target. It's SLO. And there is SLA, agreement. And agreement, it means if you don't reach the target, you have a sanction. You must pay the fine or you go to court. It's SLA, agreement. So what is the SLA review? Every month, every team, every engineer at Yandex Taxi goes to special dashboard with a latency, uptime, availability, hardware resources, mobile metrics with a set of targets. For example, we log every timing of when you open a Yandex Go app, we log how fast the screen paints. It's SLO, and we have a target, like it should be opened in 100 milliseconds. And if we don't reach this target, if the screen of Yandex Go opens too slowly, we must have a corrective action items every month. So it helps us to first to set the goals of quality and reliability. And second, it's continuous improvement, like Japanese Kaizen. Maybe you heard of the term Kaizen, continuous improvement. That's the processes that help us stay reliable, have less incidents, and get good quality of our service. Okay, thank you. And the last pillar of reliability are software tools. And they make the system reliable directly. That's what backend engineers do. So they help us to protect user experience, prevent outages, and they work together with processes and goal settings. Yeah, have a talk. I think it's for 1 hour, so you can scan QR code, the whole talk about our tools, because now it will be very fast talk. But if you want to give you a minute. Okay. Yes. Again, another talk, article. Tools. Chaos, auto recovery, graceful degradation, virtual orders, even board, and SRE GPT. Let's talk about each of them. Each one. Chaos. To expose weak points and hidden dependencies. We have a team, we call them chaos sites, house seats. We have microservice architecture, 1000 microservice. It's a lot. It's a distributed system, and every microservice is somehow linked and dependent on different microservice. And we don't know how. For example, not every service is equal for impact. For example, the order button is very important. You can have a write without order button, or you can have a write without prices. If the service that calculates prices by algorithms of Sergey doesn't work, you can have a write. But you have a service that shows color of the car. Is it important? Color of the car? It's nice, but we can live without it. So, all of our services are rated by tiers, where tier A is most important. We can't live without it. Calculating prices, showing cars, showing order button, it's tier A. If it doesn't work, taxi doesn't work. We have 36 tier A services, only 36 from 1000. Second, tier B. Tier B are services we can live without for 1 hour. After 1 hour, it's bad for business. It doesn't work. It's like driver activity or some other services. And tier C services are services that we can live without indefinitely, like the color of the car. If it doesn't work, it's bad, but it's not fatal. But how we identify which service is which tier? Chaos. Chaos is a technical system of fault injection, where we can say to any service how to react and which error to return. So we can say, this service must return timeout, or this service must return HTTP error 500s. You all know HTTP errors like 503 or 2. And then we can see how the system and other microservices react to these errors and timeouts. And after that, we can be sure that the system can work without this service. Before that, we are not sure, because chaos help us to find unknown unknowns, where you don't know how it reacts. For example, there is a service that shows user agreement. And I want to ask, is it important to have a right without user agreement? What's your opinion? Logically, intuitively. Yes. No. Well, no. Actually, it may be one time when you open the app for the first time and you agreed, maybe it's important. But after you use it, it shouldn't be important because you already agreed, right? But with some buggy release, it's not so. And if the user agreement doesn't work, you can have a right. It's a bug. It can be only found with chaos by testing it. So every service at Yandex Taxi has chaos drills for 3 minutes. For 3 minutes, every tier C and tier B service doesn't work. And we see how the system reacts. And we write it down. And then we fix it. Okay. So it helps us to struggle with complexity of the distributed system. Yes, it's about chaos. Next tool is auto recovery. Auto recovery is a self-healing system that reacts to monitoring alerts. And if the taxi is down, it turns on graceful degradation, and in 5 minutes, it starts to roll back releases. So basically, it's a bot that do same thing as a human, some kind of. And graceful degradation, why we need it? Because it prevents metastable and cascading failures, and it stretch capacity under stress. It gives us capacity. What is a metastable failure? Metastable failure is when your system is in a fragile state and it doesn't have margin of safety. Margin of safety is you have CPU and you have hardware. It's margin of safety for peak loads. And when you don't have it, the peak load at Friday night breaks your system down. You have a downtime. And metastable failure, when you can go up because of the traffic, because people order, retry, F5, 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 and you can go up. So you need to degrade. You need to degrade to have more CPU, more memory, and more capacity to go up. So it shortens downtime. What is technically? Technically, degradation is a button that turns off unneeded, some kind of unneeded functions, like animation, like some database guarantees, multiply orders. For example, in our app, you can make multiple orders for you, for your sister, for your mother, etc. When we degrade, you don't have it because we need more capacity. So it's a degradation. Next one is my favorite, virtual orders, to measure true capacity of the production system. Virtual orders is or are virtual drivers with virtual riders. Right now, when we speak, there are 50 virtual drivers at Yandex Taxi that have a ride with virtual riders that emulate real-life routes. For example, from Buyuk Toran to Inha University. We have a real route, but we have virtual driver, call him Anwar, robot Anwar, and virtual rider, call him Islam. Yeah, they are robots, but we need them to test capacity. Why we can't just make a load testing with Apache Bench or Yandex Tank and just sending HTTP load 1000 requests per second to some endpoint? Because it doesn't emulate real drivers and riders, and the taxi is a funnel. When you start the order, you create the order. First, you find the driver. It's the first stage. The driver accepts your ride and starts driving, coming to you. It's the second stage. He came to you. He picked up you. It's the next. And you have a funnel till the payment is made until you reach your destination. And the order exists for 1 hour. 1 hour. So with this thing, we emulate real user and driver behavior, at least we try. And we test every service in our system. Color of the car, status of the driver, status of the rider, status of everything, hundreds of services. And with this thing, we can measure our true capacity and understand the real load. We can identify all bottlenecks. Here's we don't have CPU. Here we don't have rate limits. Here there is some bug, just bug. So every month or every week we can do it, and we have a control panel where we can say, please make a double load for a taxi. And we have 50,000 of virtual drivers, 50,000 at peak capacity. That's very important to be prepared for high season. And what is a high season for taxi? When? What's your opinion? When there is a peak loads? Winter. Okay, right, but when? Rain. Rain is under supply. When there is a heavy rain, the drivers go to home, and we have less drivers. Holidays, not always. There are some holidays when people don't want to go to taxi, they stay home. So it's winter. High season is winter, but when? Not mornings. No, not mornings. New Year. The whole year we are preparing for a new year. And it's from 22 to 2 a.m. And in every country in the world, the pattern is the same. You have spike till New Year, like 12 o'clock, and then you have no rights. No rights at all. Everyone is at home. But in 2 minutes, like 0002, everyone goes to taxi. Everyone. The whole city, the whole country want to go somewhere. I don't know where. But everyone. And we must be prepared for it with different measures. That's why we have virtual driver and virtual orders test. Okay. Yeah, it was my favorite. Next is event board. Observability. I don't want to talk about Grafana dashboards. I don't want to talk about alerts. Everyone has it. But event board, that's a thing. It's a situational awareness. Why? Because 30 to 70 all incidents on production created by buggy releases and configuration changes on production. And this system allows us to see all the changes to production order, who, when, how to roll back. And when we have an incident, we go to this system and we want to see what happened, what configuration changes or what releases was at the time, and we can roll back. 30 to 70% of incidents in a production system are changes to production. So you need to see what changed. Something changed. When something broke down, it means something changed. Okay. Also, we seek for the team member to this project. Okay, next one is SRE GPT. It's a new project. It's an R&D stage, research and development. What is it? You know ChatGPT, right? Yeah, okay, everyone knows ChatGPT. You know large language models, etc. So this thing is, it must, it's me, but robot. Yeah. So for me, I don't want to work anymore, right? So I want to create SRE GPT. It's 3 stages. First stage, this thing with AI tries to identify that something is wrong instead of a person, of human. Second stage, it identifies something is wrong and it offers you solutions like something is wrong in Tashkent. I think it's because of configuration change, and I offer you to roll it back. And it makes with AI by analyzing with LLM all the metrics, all the things that changed on production, like this thing. SRA GPT analyzes all the changes instead of human, and it says, I think this is reason, this change, please roll it back. And third stage, I think in a couple of years, this thing will try to fix production by itself without humans. Identify, offer solution, and fix it by itself. That's what it is. And that's what we call right now. It's multi-agentic system. There are different agents. One agent analyze event board. One agent analyze hardware. And one agent, the main agent, it gathers all the facts and analyzes with a prompt. The prompt is like, imagine you're Alexander Fisher, you're SRE engineer, what you do with all these facts. So we have Yandex GPT, so we can do it with Yandex GPT and our artificial intelligence. Okay, that's all I wanted to share today with you. And conclusion is that reliability is a complex issue. There is no silver bullet, but there is a silver lining that with the right set of tools, processes, and right goal setting, you can have 4 nines. You can have big, distributed, reliable system. And I hope that I gave you some ideas for your future careers as engineers, as coders, and as managers. Okay.
Thank you very much.
Thank you.
That was a great speech.